Welcome to qnawire.
In this problem, we're going to be considering a case where we're told that 20% of Americans ages 25 to 74 have high blood pressure. So we have a random sample of 16 Americans ages 25 to 74 selected, and we're supposed to find the probabilities that none will have high blood pressure, one half will have high blood pressure, exactly four will have high blood pressure. So this distribution is a binomial distribution, and in this case, since it's a binomial distribution, we're going to take the probability of success to be 20%, because it will 20% of Americans have high blood pressure. So the probability of success P is 20% or 0.2. We also know that the number of trials n is 16 because only 16 were picked. A sample of 16 has been used. So for the first part of the question A, we're supposed to give the probability that none of the people selected would have high blood pressure. So we have to use the following formula to get that probability, and that's what we'll use even for the other cases. So we say that the probability that of getting X number of successes in n trials is given by n factorial divided by n minus x factorial multiplied by x factorial, and then that's multiplied by p raised to the power of x and q raised to the power of n minus x. In this case, q will be the probability of failure, the numerical probability of failure, which is 1 minus p, and we have it as 0.8 in our case. So in the first case, A, we're finding the probability that none will have high blood pressure. Therefore, we're finding the probability that x equals 0. So we would have to substitute the value of x into this equation, in this expression, and that will be 16 factorial divided by 16 minus 0 factorial multiplied by 0 factorial, and that should be multiplied by 0.2 raised to the power of 0, then 0.8 raised to the power of 16 minus 0. Okay, and that will be, this whole section will yield, when you work that out, 0.028147. And as a percentage, that's going to be 2.8147%. In the second part of the problem, B, we're told to find the probability that one half will have high blood pressure. And in this case, one half represents 8. So the probability that one half will have blood pressure is P x equals 8. So we do the same thing. We would need to substitute the values accordingly, and that would be 16 factorial divided by 16 minus 8 factorial multiplied by 8 factorial, then multiplied by 0.2 raised to the power of 8, and that's multiplied by 0.8 raised to the power of 16 minus 8. And when you work this out, you get 0.005528. And as a percent, that would be 0.5528. 0.28%. Next, part C of the problem is supposed to get the probability that exactly 4 will have high blood pressure. So that means we're finding P x equals 4. That means exactly 4. So in this case, we'll have the following substitution: 16 factorial divided by 16 minus 4 factorial multiplied by 4 factorial, and then this fraction multiplied by 0.2 raised to the power of 4 and 0.8 raised to the power of 16 minus 4. And when you solve this, when you work that out, you get 0.2001, and as a percent that will be 20.01%.